Hello, dear CAT aspirants. I hope you all are doing a rock solid preparation for your upcoming CAT exam. So, today we bring to you another topic from your logical reasoning section, that is number series. Although this topic is not that important from CAT point of view because it is not mandatory that a question from this topic will come or will surely come in CAT exam. Although, when you have done a lot of practice, you can switch to this topic because you never know, you may get one or two questions out of it. But yes, as per my observations of PYQs and data, every year the question from this topic is not that asked. So if you ask me to rank the topics in your logical reasoning section, I would keep number series somewhere towards the end, but it doesn't mean that you don't have to prepare this topic. See, actually number series will help to develop your analytical skills. You will basically analyze for patterns in it, and this is what is required when you go further for your MBA. So it is important to brush up your skills. Also, the skills brushed up through this topic can help you in other ways as well. Then you know you have a similar chapter of series in your quant. So the knowledge from here can help you in solving some questions from that topic as well. So without wasting any time, let us quickly talk about that what should be the correct approach to study this topic. See, sequence or series is basically a pattern. It is basically a pattern that is fixed throughout. It means that pattern is not random. There is obviously some pattern between the things. For example, if I say 2, 4, 6, 8, 10, then you can see that you can complete this series till infinity because you have recognized the pattern in the very beginning that these all are even numbers increasing with a factor of 2. So next will be 12, then 14, 16, and so on. So this totally depends upon how well do you observe the patterns around you. So there's no fixed strategy to solve it because everybody has their own observation skills. So this depends totally on your observation skills. How well do you observe the things? So you have to keep an open mind as the topic is very subjective. Your way of starting a question may not be similar to my way of starting the question. But yes, one thing which you can sure shortedly do is please, please, please learn squares of numbers from 1 to 30 and cubes of numbers from 1 to 30. See, I know squares till 1 to 20 most of you must be aware of, and I think you should be aware of because it is very important. But then if you are expecting an exceptional performance in your exam, 1 to 30, or if you can do it from 1 to 40, nothing like that. I'm talking about squares. If you can do it from 1 to 40, nothing like that, but 1 to 30 is mandatory. It is mandatory. This is not going to help you just in series. This will also help you in your entire preparation for the CAT exam. Similar way, you have to learn the cubes of natural numbers from 1 to 30. For cubes, 1 to 30 is enough. See, 1 to 10, everybody, even me, everybody know that. But 1 to 30 is something that is going to make you outshine during your exam because it will save a lot of time in calculations. And when you will recognize those numbers, it will be easy for you to recognize those patterns. Like, for example, if somewhere I see 343, it should quickly strike my mind that it is 7 cube. So that this observation only comes if you have learned it. So paste the list on your wall, notebook, make it your phone, laptop wallpaper, do anything, but please do it at any cost. This is very, very important. So if you have your notebooks with you at this moment, I would recommend you that please pause the video and please note down this list. Please make a list in your notebook and keep on revising that list, after your breakfast, after your lunch, and after your dinner. Just like, a doctor guides you for medicines, please learn the squares and cubes with your heart. So, basically till 10, it's very easy. 1, 4, 9, 16, 25, 36, 49, 64, 81, 100. Then I expect till 20 also each one of us know. Like if I ask you what is 13 square, it should quickly strike your mind that it is 169. 19 square, 361. But the problem lies here. Many of us do not learn this part, and this is what is going to outstand. This is what is going to make you outstand. So please learn them with your heart. Similar way, these are the cubes. You can see one cube is one, very easy. Then, four cube, 64, eight cube, 512, 15 cube, 3375. This is very much used, right? Then 18 cube, 19 cube, so on till 30 cube. This you have to learn. So this is something that you have to do it at any cost. This is not just for number series. This instruction is not just limited to number series. Rather, this will help you during your entire preparation. Okay, now before we go into solving of questions, as I told you that the topic is very subjective, if I give you a series, I cannot tell or you cannot tell what type of series it is before solving. Until and unless you have arrived at the answer, you cannot tell what is the type. So here I have summarized some types of series which are commonly seen, but then the series that may be asked in the exam may be a combination of these. So basically, the idea of introducing you to the types of series is that you know what are the basic kinds of series, so that when you see numbers like this, something should strike your mind immediately, which may help you to solve the question. As I told you that if you remember the squares and cubes, this will help you a lot in recognizing patterns, because many patterns are based on squares and cubes that we will see in the further course of time. So the first type of series can be pattern in the difference or addition factors of consecutive numbers. So what do I mean? As I gave you the example in very beginning, like 2, 4, 6, 8, 10, you could see that the difference or the addition factor over here, plus 2, plus 2, plus 2 every time. So there was no pattern. It is basically fixed. Now there may be series in which the pattern of the difference or addition factor can be seen. Like let's take this example. You have 61, 45, 36 and 32. So if I try to take out the difference of 61 and 45, so this is basically minus 16. From 45 to 36, please open your on-screen calculator. This is 9. From 32 to 36, how do you arrive? Minus 4. So basically you can see, if you look at these numbers and if you remember the squares now, so you know that these are squares of 4, 3 and 2. So this is in the decreasing order. So now next number would be a subtraction of 1 square, that is minus 1. So 32 minus 1 is 31. So you can see that this is a kind of difference series where the concept of squares is also used. So this was very easy to guess. Let's move to the next one. So 242, 289, 332 and so on. So let's first find out the difference. 242, so we'll add something to it. We'll add 47 to get 289. From 289 to 332, we arrive by adding 43. Similar way, 332 to 373, we arrive by adding 41. 373 to 410, we arrive by adding 37. Now, if you look at these numbers at first, we may not be able to recognize that what are these numbers. But if you remember a little bit of what you have done in your junior classes, you know that these are prime numbers. Again, an important instruction comes into play. Please remember prime numbers from 1 to 100. See, 1 to 50 is not a deal. 1 to 50, anybody can write down, very easily. 1, 2, 3. Will 1 come in this? No, 1 is neither prime nor composite. Please remember this. I wrote it intentionally. It is neither prime nor composite. Your prime numbers start from 2. So 2, 3, 5, 7, then 11, then is 13, 17, 19. Then you go after 20 is 23, then 29, then is 31, 37, then is 41, 43, 47. So till 50, I think it must be on the tips of everyone, but I would recommend please learn prime numbers till 100. So again, please make a note of this in your notebook. Wherever you are noting down the things, please pause and make a list of prime numbers till 100. This is also something that you should know. So over here, you can see that the numbers are increasing in a pattern that always a next prime number has been added, or I would say decreasing prime number has been added. 47, 43, 41, 37. So the prime number before 37 is 31. So the next number that will come in the series will be an addition of 31 to this. So when you add 31 to 410, you get 441. Also, sorry, also you can check for the correctness of this, because next number is also given 470. So this means that it should be plus 29. So is it plus 29 over here? Yes, it is plus 29. So like this, you can check the correctness as well. So I hope now you are understanding that how do we recognize the series. Those who are at an advanced level in their preparation will find this video of a basic level, but let me tell you, do not underestimate some such things, because sometimes our mind is tuned to solve difficult questions and we do not notice such easy patterns. So it is always better to practice each level of question: easy, moderate, and difficult. Okay, now let's move to the next one. 4, 12, 39, 164, 507, and so on. So let's just see what is the addition factor over here. So 4 plus 8 is giving 12. Now 8 plus 27 is giving 39. 39 plus 64, I guess. No, not 64. 39 plus 125 is giving 164. After this, 125, then plus 343 is giving 507. So you can see 12 can be written as 4 plus 8. Then 39 can be written as 12 plus 27. 164 can be written as 39 plus 125, and so on. Now, if you look at these numbers, it should quickly strike to your mind that these are cubes. These are cubes. So this is 2 cube, 3 cube, 5 cube, 7 cube. So we have the addition factor in the sequence: 2 cube, then 3 cube, then 5 cube, then 7 cube. Now many people in excitement will add 9 cube next and make the number, but be very careful, these are not odd numbers, because 2 is also here. 2, 3, 5, 7, these are prime numbers. So next on the list will not be 9 cube, rather it will be an addition factor of 11 cube. That is the next prime number. So 11 cube, if you go back to the list, is 1331. So 11 cube is 1331. So it means next number will be nothing but 507 plus 1331. So that comes out to be 1838. I hope each one of you is using your on-screen calculator and is trying to become handy with it, each day becoming better with the usage of it. Okay, let's come to the next one. In the next question, we have 12, 22, 42, 82, 162, and so on. Like over here, you can see, everywhere the units place is same, 2, 2. So I think I can do it easily. Let me try to find the difference. So first is a plus 10, then is plus 20, then is plus 40, then is plus 80. I guess there's no need to explain. You must have understood that every time the addition factor is becoming the double of the previous one. Like 20 is 10 into 2, then 40 is 20 into 2, 80 is 40 into 2. So the next number will be 160, that is 80 into 2. So when you add 160 to 162, you get 2 322. So the next number over here will be 322. So you can see how easy this question was. Okay, so now let's move towards the next type of series, that is multiplicative series, and this is a very common type of series that is asked in exam, because generally difficult questions are framed from kind of multiplicative series. And one way to identify this type of series is that the first term and the last term are very different. There's a huge difference between the two. This will not happen in the case of the type of series we saw previously, that were addition and difference ones. Over here, you will see that the first number and the last number, there's a huge difference between the two. Like you can see over here, the first number is 5 and last number is 143. So you can see a huge difference of 138 is there. Similar way, first number is 3, last number is 260. So you can see a difference of 257. So this is an indicative. I'm not saying that this is sure, but this is an indicative. An indicative of multiplication series is that there's a huge difference between the last and first term. And this is not something sure. This may happen in addition or different series also. Like you saw this series where the pattern was, increasing as double. So over here also there's a huge difference. But commonly for multiplicative series, this is an indicator that there's a huge difference between the last and the first term. Also, the reverse of multiplicative series becomes a division series. If I reverse the series, it becomes a division series. That is why I have not made another category of it, because this is one and the same thing. If you reverse the series, it will become division series. So if you see a decreasing series and you identify this as a division series, it is better to convert it. Like I personally find multiplicative series easy. Like, it's a psychology that when I multiply, I find the thing easier. So I always, reverse the series to get the correct answer. So you can also do that. Otherwise, if you are comfortable with this, you can proceed with this as well. Okay, so now let's have a look at the examples. So first one is 5, 7, 11, 37 for 143. So if you didn't know that this is multiplicative series, the first approach that everyone, me even, you also, we would apply was that we'll take out the difference. Like over here, it is plus 2, then it is plus 4, then you would get happy seeing that okay, there may be some pattern in the difference. But then you go further, then when we go further, this becomes 26, then this becomes plus 106. So now there's, we can see there's no pattern in this. So obviously there's some other logic used in it. So let's try with multiplication. Now if I want to write 7, I can write 7 as 5 into 1 plus 2. I hope this is clear to everyone. If I want to write 11, I can write down 11 as 7 into 2 minus 3 very easily. If I want to write 37, I can write down 37 as 11 into 3 plus 4. If I want to write 143, I can write it as 37 into 4 minus 5. So I can see some pattern. You can see previous number multiplied with the sequence 1, 2, 3, 4. So next number could be 143 into 5, and you can see alternate plus minus plus minus. So plus minus plus minus. So next will be plus, and 2, 3, 4, 5. So next should be 6. So this should be the next number according to me. So when you solve it on your calculator, you get 715 plus 6. So that comes out to be 721. So you can see that this is a kind of multiplicative series because some sort of multiplication and then combination of addition and subtraction is involved. So that is why it becomes difficult to identify patterns in such kinds of series, because there can be infinite patterns, and out of that, if you are fortunate enough, your brain may work in the very first chance on the first pattern, correct pattern only. So that comes by practice and identification. I told you learning squares and cubes will help you to identify the patterns better. Okay, let's move to the next question. Okay, so now let's come to the second question of multiplicative series 3, 5, 16, 60, 260, and so. So now also you can see that the difference between the first and the last term is huge, but a layman approach would be to find the additive factor. So over here it is plus 2, over here it is plus 11, over here it is plus 44, then it is plus 200. So you can see that there is no pattern. So this is something different from addition or subtraction, maybe a form of multiplicative series. So if I try writing 5, can I write 5 as 3 into 1 plus 2? I can write that. If I try writing 16 in terms of 5, I can write it as 5 into 2 plus 6. If I try writing 60, it is like, 16 into 3 plus 12. If I try writing 260, it will be 60 into 4 plus 20. So now if you look at this particular thing, you can find a pattern. 1, 2, 3, natural numbers are increasing. But now if you look at this, there's no pattern. Now what we will do in a haste, in a hasty thing, we'll leave this and we'll try something else. We'll start trying something else. But now if you observe these numbers carefully, there's a pattern hidden inside them. 2 can be written as 1 into 2. 6 can be written as 2 into 3. 12 can be written as 3 into 4. 20 can be written as 4 into 5. So see, there's a pattern inside pattern. So earlier these numbers were looking very vague, were looking very disordered. There was no sort of pattern being reflected. But when I broke these numbers in multiplication, I found that there's a pattern in these numbers as well. So it is 1, 2, 3, then 2, 3, 4. So this way, if I try writing the next number, it will be 260 into 5 plus 5 into 6. So that means 260 into 5 plus 30. So when you solve this, you get 1300 plus 30. So that is 1330 is the next number. So you can see pattern inside pattern. So there's a pattern in pattern. So such kind of questions are very, very famous in amongst the examiners, because this is somewhere, where you will stop. You will think that there's no pattern. Okay, let me think of something else. And, you will leave after trying so much and wasting your so much of time. So please be very careful. Please look at each and every number carefully in context to the previous number. Okay, let's move to the next one. 3, 9, 32, 167, 1178. So looking at the first two numbers, you will quickly write it as into 3. Then you will see, okay, 32, I can write it as 9 into 4 plus 4. Okay, then let me try writing 167 like this. So it will be into 5 plus 7. Then let me try writing 1178. So this will be something into that, but again this is not useful. You can see, because there's no pattern. There's a pattern over here, into 3, into 4, into 5, but then plus 0, 4, 7 is not making any sense, right? So let me try something else. If I try to write 9, I can write 9 as 3 into 2 plus 3. I hope this everybody of you can think of. 3 into 2 plus 3. So if I try writing 32 now, so 32 can be written as 9 into 3 plus 5. Then 167 can be written as 32 into 5 plus 7. 1178 can be written as 167 into 7 plus 9. So yes, now I can spot some pattern. 2, 3, 5, 7. You can see that this is a sequence of prime numbers in the increasing order. So these are prime numbers. If you look at 3, 5, 7, 9, so these are odd numbers. So what should be the next number according to this? So next number should be 1178 into next prime number over here will be 11 plus 3, 5, 7, 9, and next odd number will be 11. Now, what is a common error that people will do? They will quickly recognize the pattern, and without looking at this 2, they will think that, okay, this is a series of odd numbers, 3, 5, 7, and then quickly they will jump to 9, making the question wrong. Please be very careful. There's a 2 in the beginning, so these are not odd numbers, rather these are prime numbers. And in addition, we do have odd numbers. So when you multiply this, you get 1, 2, 9, 5, 8 plus 11. So when you solve this, you get 1, 2, 9, 6, 9 as the next number. So you can see a huge difference between the last and the first term. So there's a difference of 1, 2, 9, 6, 6. So obviously this was a multiplicative series, but a combination of multiplication and something in the factor of addition as well. Okay, so now let's move to the next question. 4, 6, 15, 52.5, and so on. Now, in the questions where you see terms with decimal, this is my, personal experience, or I would say my personal observation, that whenever I see number like decimal, I do try multiplication with fractions. I do try multiplication with fraction, because 90% of the time this becomes the case. When you see decimal, it is possible that there are some sort of fractions like 1 by 2, 3 by 2, 5 by 2, 7 by 2, 9 by 2, and so on are multiplied. Let's check in this case, like to arrive at 6. By what fraction should I multiply 4 with? Then 4 into 3 by 2 will give me 6. Similar ways, 6 into 5 by 2 will give 15. Similar way, 15 into 7 by 2 will give 52.5. So presto, we found the pattern. So next number would be nothing but 52.5 into 9 by 2. So when you solve this, you get 236.25. So we got our answer. And let me tell you, this observation of mine will work in many questions involving decimals. So whenever you see decimals, please try multiplying with some fraction. Okay, so now let's move to the next type of series, that is Fibonacci sequence. Very easy, yet this is very, very underestimated. This is very, very underestimated. People think that such easy question cannot be asked, but then in exam, there may be a question out of Fibonacci sequence. This is very easy because generally a term is the sum of previous two numbers. Like if you look in this series, 1 plus 1 will give you 2. 1 plus 2 gives 3, then 2 plus 3 gives 5, then 3 plus 5 gives 8, then 5 plus 8 gives 13, and so on and so forth. So you can arrive, till infinity over here. So now this kind of sequence is very easy, but it is not that it is always asked like this. There may be some sort of variations in the questions asked from Fibonacci sequence. It may be a type of Fibonacci sequence, but may not be exactly like this, right? So let's have a look at the questions. So question is 17, 26, 43, 69, 112, 181. So now being a layman, our mind has been tuned that the questions are lengthy, tedious. So we'll, try solving it, finding the addition factor, multiplication, and, we'll try doing the whole maths of the world. And at the last, we'll realize that this was a Fibonacci sequence. So now, before trying for any tedious calculation in the exam, I would actually advise you to try once for Fibonacci. It is possible that the question may be of Fibonacci sequence. Like over here, you can see 17 plus 26 is 43. 26 plus 43 is 69. 43 plus 69 is 112. 69 plus 112 is 181. So next number would be 112 plus 181, that is 293. So easy. And I'm sure that, we'll waste a lot of time on this. Now, because you are listening to me, this question has been placed under the category of Fibonacci sequence. So it must be Fibonacci sequence. But then in exam we generally, out of pressure, we generally do not try such easy things. We think that the question must be difficult because it is in CAT exam or any MBA exam. So once, before wasting your time trying some lengthy calculation, please try for Fibonacci once. It is possible that you may get your answer in the very first chance. Okay, now let's come to the next one. So 1 1 3 2 4 5 6. Now looking at this, this is not a direct Fibonacci sequence, and generally when we see a number twice, we try to break the series into two. Like many people will try to look it from the angle 1 3 4 6 alternate, then again 1 2 5, and so on. So again, this can also be the case, but in such cases Fibonacci is also possible. There are high chances that the question may be of a Fibonacci sequence. Like it is not a direct one, but if you look carefully, 1 plus 1 is 2, then 1 plus 3 is 4, then 3 plus 2 is 5, then 2 plus 4 is 6. So next number will be 4 plus 5, that is 9. So easy, you can see, right? So please try for the Fibonacci once before going to any tedious calculation. Let's come to the next question. So this question I would say is a good question. You have a hint over here that this is Fibonacci. Still, I challenge you that you please pause and try solving this question. Do you get anything out of Fibonacci? Because this question is not just Fibonacci, it is Fibonacci plus the concept of sum of digits. And this is again one of the favorite concept of the examiners, who are setting the exams for, especially for competitive exams. Now, by sum of digits, I mean that, if the first number over here is 11, so the digits of 11, they sum up to 2. Now 2, so you can see some link with 2. So the next number is 11 plus 2. Now the sum of digits of 13 is 4, and you can see the next number is plus 4. 17, sum of digits is 8. So the next number is again plus 8. 25, sum of digits is 7. So next number is plus 7. 32, sum of digits is 5. So next number is 5. 37, sum of digits is 10. So next number is 47. And so next number will be 4 plus 7, that is 11. So plus 11. So that will be 58. So this question was indeed a good one and a tricky one. So it becomes difficult to recognize patterns like these because they have two concepts involved, sum of digits and Fibonacci. And this is the kind of questions asked in the exam. And let me tell you, this is a PYQ, not from your CAT, but from your SNAP exam. That is also an MBA entrance exam. You all know that. So, see, now till now we have discussed many types of series: addition, subtraction, multiplication, division, Fibonacci, and we have, done 3, 3, 4 examples of each. But this is not the end. For this topic, you have plethora of sources. You will get sea of questions. You will get plethora of questions on internet, in your books, whichever book you are following, Arun Sharma, R.S. Agarwal, whichever book you are following, you will get plethora of questions. I would suggest, please, try solving the questions, because there's no end to this topic. There can be infinite questions. So the only motive over here, my motive over here, is to make you, skillful in the act of identifying patterns. But the mastery you will gain is only by practice. So the only key is practice. Please practice more and more. You have plethora of sources. There is no shortage of sources. Please practice more and more to gain a mastery onto this. So how will this help? In exam, obviously you are going to get a different question, but this would help because your brain is, it is tuned to identify pattern, and this will increase your analytical skills as well. You will be able to identify patterns quickly. Okay. So now let's move to the next type of series, that is squares and cube series. This is indeed a difficult one. A difficult question can be framed out of these. So the best way is to crack is that you have to learn these. Now again, one more thing to learn: special types of series, squares and cube series. They involved arithmetics of squares and cubes, cube plus number, cube minus number, cube plus square, cube minus square. So these are the four basic types: n cube plus n cube minus n cube plus n square, n cube minus n square. So now what is the purpose of this? See, when this kind of series come in exam, it takes a lot of time to arrive at the pattern. It takes a lot of time to strike such kind of pattern. So my motive of telling you to learn is that you become familiar with numbers like these. So that when you see numbers like these, you can quickly identify that, okay, if it is not addition, if it is not division, if it is not subtraction, if it is not multiplication, if it is not Fibonacci, then it can be something of this form. And sometimes even in differences of two consecutive numbers, this kind of pattern may be there. So, again, pattern in pattern. Sometimes, you have done everything of the world around you, but then also you are not able to identify. If you look at the difference or the addition factor, that may be of this particular form. So this is something that students or aspirants, they tend to ignore. But then there's a difficult question that can be framed out of it. It is actually not difficult. It becomes difficult because we are not into the practice of thinking that this could also be possible. Right? So over here, n is 0, 1, 2, 3, 4, and 5, and so on. So let's try to frame the first kind of series, n cube plus n. So in the first case, we'll keep n is equal to 0. So 0 for 1, it will be 1 plus 1, 2. For 2, this will become 8 plus 2, that is 10. For 3, it will become 27 plus 3, that is 30. For 4, it will become 64 plus 4, 68. So for 5, it will become 125 plus 5, that is 130. For 6, it will become 216 plus 6, so triple two, and so on. So I would recommend, please learn till n is equal to 6, so that whenever you see a series like this, you can quickly identify that this may be the pattern. So generally we try to find pattern between two numbers, and then we realize that, okay, over here the independent number had a pattern, common pattern. So independent number is having a common pattern, but there is no pattern, there is no connection between the two numbers. So this kind of question is also possible. And generally in series, we do not think like this. We always try to find the pattern between two consecutive numbers. So it is very important to learn to identify such kind of numbers, so that when they appear in front of you, you can guess that it is it. And also, if examiner wants to make the question a little difficult, it is possible that the examiner may not take the series starting from n is equal to 0. Maybe the series starts from n is equal to 4 and goes on till n is equal to 9. So over here, so now it is, so there are number of permutations and combinations possible, and can be anything. And that is also true that as aspirants, you cannot learn all the permutations and combinations. But the motive of learning the basic one is that it gets fit into your brain. So what are we doing over here? We are tuning our brain to identify such numbers. So that tuning will come if you learn the basic one, then it will be set in your mind. It will be somewhere in your subconscious mind that, okay, let me try this. It may be possible, right? And if you are fortunate, you may get your answer in the very first chance itself. Okay. So now let's go into the next type of series, n cube minus n. So n cube minus n, if you keep n is equal to 0, so 0, 1, again 0. So, see special type of pattern, 0, comma 0. So many a times we may get confused looking why 0 two times, right? Next is 2. So 2 is 8 minus 2, that is 6. When you put n is equal to 3, so 27 minus 3, so that will be 24. N is equal to 4, so that will be 64 minus 4, that is 60. N is equal to 5, 125 minus 5, 120. N is equal to 6, 216 minus 6, so that is 210, and so on. So again, please try to remember this series from n is equal to 0 to n is equal to 6. So let's move to the next type of series, that is n cube plus n square. So series of the form n cube plus n square. So if we put n is equal to 0, we get 0. If we put n is equal to 1, so 1 plus 1, 2. N is equal to 2, so 2 cube is 8 plus 2 square is 4, so 12. Then we put n is equal to 3, so 27 plus 9, that will be 36. Then n is equal to 4, 64. So 64 plus 16 will be 80. Then n is equal to 5, so 125 plus 25 again 150. N is equal to 6, so 216 plus 36 will be 252, so 252. So on, this series also goes on till you can learn it till n is equal to 6, but it goes on till infinity, right? Okay, so now next series is of the form n cube minus n square. So for n is equal to 0, 0. For n is equal to 1, again 0. N is equal to 2 will be 8 minus 4, that is 4. N is equal to 3 will be 27. 27 minus 9. So 27 minus 9, will be 18. The next will be 64 minus 16. So when you do 64 minus 16, you get 48. Then will be 125 minus 25. So that is 100. Then 216 minus 36 will be 180. So on. So again, please learn this series till n is equal to 6. Now basic motive over here is that you try to identify, especially if you see double zero, if you see double zero, then you can directly check for n cube minus n or n cube minus n square. Fine. So this type of series, this may be a direct series or maybe a pattern present in difference or multiplication. So please check for such patterns as well. Please learn them. Please note them down somewhere. Pause the video and please note them down somewhere. So with this, we have discussed all the types of series that are possible. And in coming videos, we will be practicing questions based on series. So this was a very, very important lecture. I hope you all have noted down the squares from 1 to 30 and cubes from 1 to 30. And from today onwards, please start learning them so that till your exam time, they are on your tips. Goodbye until next. So now that you have understood the topic through our videos, I would recommend you to try the practice tests of the topic number series available on our EduRev app. Apart from the tests, we also provide a full fledged course to support you in acing your CAT preparation through 170 plus interactive videos and video lectures, 150 plus comprehensible documents, and 110 plus tests comprising topic wise, section wise, and 20 plus full length mock tests. So keep on doing your rock solid preparation and quickly go and check it out on our app.